sure we're not.
Hello.
Tell you before you do your PreAP.
Not echoing. Not echoing. Not echoing. Ha! Okay. Got it. 8.1. We're talking about a new kind of function. Right, Whitney? New kind of function. Yay. It is called an exponential function. Yes, you have probably dealt with these before because they're very, like, applicable to life and, like, interest and those sorts of things. Like interest on a loan or a car or something. And really a lot of things. I don't know. It's just different. Okay. In this, the independent variable, which is which one normally for us? X or Y? X. Yes, the independent variable X is an exponent. All right, this is the general form here. Y equals A times B to the X. All right, so we see X is the exponent. That's what makes it an exponential function. Okay, X has to be a real number. A cannot equal 0. B has to be greater than 0, so B has to be positive. And B cannot be 1. Okay, so there's lots of little stipulations here about A and B. No, because it could be between 0 and 1. It could be like a half. Or you'll deal with some of those. Okay, the domain and range for these are all real numbers in general, and then for specific equations, it'll be more specific. Like for the example over here, the y, the range would be everything greater than 0. But just in general, these functions have the ability to be anywhere. All right, so there's really, we have two different types of exponential equations. We have the growth and decay. Does that sound familiar? Exponential growth and exponential decay? A little bit. You probably should have done a little bit in Algebra 1. All right, so when b is greater than 1, we model growth, and this is, b is called the growth factor. Okay, so B definitely is very important in these. It has a special name. It's the growth factor. So that's when it's greater than 1. This graph is an example of exponential growth. See how it goes up? It's growing from left to right. So that's exponential growth, which means B must have been bigger than what? 1. Yes. Exponential growth, B is greater than 1.
But it isn't on the left side of the graph.
Huh? B, not X, B. Talking about B. So we don't really know what the equation is for this. All we know is B is greater than 1.
How do you know that?
Because it's growth. It's going up. Just trust me. Trust me. Yes, okay, so let's graph one. We're going to do the whole thing where we pick some X's, plug them in, and find y. So let's just make a list here. Start with -3, and go all the way to +3. So we're going to plug x in to find y. So if we plug x in, our equation was 2 to the x. So we'll have 2 to the -3. Somebody figure that out? What is that? 0.125, which is the same thing as 1/8. All right, can you go down the line and figure all those out? No. Well, starting at the bottom, or in the middle, what's 2 to the 0? 1. Anything to the 0 is 1. What's 2 to the first? 2 squared. 4 and 2 cubed? 8. Okay, so we just have 2 more to figure out. You can use a calculator or you can do it in your head. Negative exponents just mean that it gets pushed down to the bottom, right? So here, that's the same thing as 1 over 2 squared, so that'd be 1 over 4. The next one would be 1 over 2. So if you want those in fraction form, you can. All right, now let's just graph these. So I'm just going to put my axes kind of in the middle. Oops, that is not the middle.
What is going on?
Try again. That'll be my y. That'll be my x. Okay, so that's my y, that's my x. Now I'm going to graph the points. So I need to graph -3 and then 8. So just barely off the x-axis.
Did you say 8?
Eighth. -3 and 8th. 1 over 8. 0.125. Okay, -2 and a 4, so just barely up. -1 is a half. 0, 1, that's an easy point. 1, 2, 2, 4, 3, 8.
Why does it jump so much after that?
Huh?
Why does it jump up so much?
Because it's exponential. It grows. I get it. Yeah, it's because it's exponential. Huh?
It starts doing that at 0 every time?
As long as it's not translated. Moves around with H and K. We'll get to those later. Okay, so then you can kind of trace it. So it goes on and on forever. Up and to the left. So that's y equals 2 raised to the x. All right, for example 3, we're going to create a exponential function, and it gives you the form to start out with. Okay, that's the general form. That's what we're going to use a lot. And then it gives you 2 points, and so we have to create a function out of that. All right, so that means y and x, they'll just stay, but what we need to find are what? Yeah, so we need to find A and B. So let's start out with the information that we have. So I'm going to sub a point, so 2, 2, into y equals AB to the x. So that looks like 2 equals AB squared. We okay so far? Follow what I'm doing, and then you can use these steps every time on your homework. Okay, next is solve for, we just want to get one of those variables by itself. I'm going to go with A since its exponent is 1. So solve for A. So out of 2 equals AB squared, I can divide both sides by B squared. So what does A equal? 2 over B squared. Very good. Okay, so that is important. We'll come back to that. Now, we are going to substitute the other point, so 3, 4, and what we just found, that A equals 2 over B squared, into that original form. Y equals AB to the x. Do I need to slow down some? Yeah. Okay, so for y, I'm going to put in 4. For a, I'm going to put in 2 over b squared. B stays the same. And then for x, I'm going to put in 3. So 4 equals 2 over b squared times b cubed. Next step is solve for the only letter we have, which is b. Okay, so how do y'all want to write this? How do you want to do it?
4 minus 3 decay.
It's multiplied over there, so we can't subtract it.
So divided by decay.
Yeah, I think we can simplify the b's a little bit. if I put all that in one fraction here, what happens to the b's?
They cancel and it's just 2b equals 4.
Yeah, okay, so we have 4 equals 2b, so what does b equal? 2. Yay! Another important thing. We actually found one of the things we needed to get. Good deal.
How could we do that can we do that if we don't simplify, or put b in the same fraction, I mean?
You could eventually get there, but you might take extra steps. You can get there. Okay, so what do you think we should do now?
Plug 2 into the equation.
Plug, what'd you say, Chris?
Plug 2 into the
Yeah, so solve for A now. Well, that didn't work out. Solve for A by substituting. So I'm going to get A equals 2 divided by 2 squared. So 2 over 4, which is 1/2. Yay, we found both of them. So now, last thing, sub A and B into the y equals AB to the x. So it'll be y equals 1/2 times 2 to the x. And I would put at least one of those things in parentheses just so it doesn't get confused. But that is your answer. Lots of substituting and solving, substituting and solving. What we just talked about was exponential growth. Okay, so fill that in. Exponential growth happens when b is greater than what? 1. All right, and b is called the growth factor. Okay, the opposite thing is exponential decay. This occurs when b is between 0 and 1. So if you want to write that as an inequality, it's 0 is less than b is less than 1. Okay, so b is somewhere between those two. And guess what b is called now? The decay factor. All right. We still use the same little formula, y equals a times b to the x. But now b is just somewhere between 0 and 1. So it's like 1/2 or 2/3 or 0.3 or something like that. Okay? So we are going to determine whether an equation represents growth or decay. So what part of this equation should we look at? The b. Which part is the b? b equals 0.95. So is that growth or decay? Decay, because it's between 0 and 1. Ta-da! Okay, what do we need to look at in the next one? Which is? So what is this one? Easy enough? All right, so this one would have a graph that goes up. This one would have a graph that goes down. Something like that. That's not very pretty. So we're about to graph those. This is the same as we did before, but we're going to add in the word asymptote. Have we dealt with asymptotes in this class? Yay. Okay. The asymptote here is horizontal. I'll tell you what an asymptote is. You can write it down. Asymptote is a line the graph approaches but never actually touches. Line